Morning, everyone. We'll just let everyone kind of get into the room before we start the session. Just another minute or so. Okay, we'll get this started. Today's session's thin brick. Oh, okay. Hi, Steve.
Hey, how are you?
Good, good. We have a few attendees in the room. If you want to give yourself a little introduction, I think you can see the screen here.
Yes, I can.
Awesome. And then when you give me the go ahead, I'll get started.
All right. Well, I'm Steve from Arriscraft here in Ottawa. So you can go.
Right on. Thank you so much.
Thank you so much for taking the time to join me today. Today we're going to talk about thin brick, an exploration of unlimited options and potential. So, as I did with the poster walls, we talked a little bit about who our companies are, what kind of products we represent. But when I created that presentation, there's a need of what kind of cool detailing can we do. When we created this presentation, it's more of what all can we do with it. I mean, we know brick. Full bed brick. We've been building this way for 100 years plus. We know the quality of brick, how long it lasts and performs. What a lot of people don't know is what all we can do with thin brick. It's the same beauty, benefits, quality. We're kind of just getting a thinner product that allows for different ways of installing it. And so I want to put this presentation together just to show the vast array of things you can do with thin brick. So again, if you don't know our companies, we're owned by Universal. We're the largest frame manufacturer in the world. We are absolutely leading the way when it comes to the quality of materials, the way we build, research and development, sustainability. We absolutely lead the world in that way. Here in North America, we're owned by General Shale. General Shale is growing to become one of the largest clay manufacturers here in North America. We've had multiple acquisitions over the past few years. Brands you might know, Columbus Brick, Paper Cut Brick, very unique texture, edge. Watsontown Brick, amazing brick line in Pennsylvania. We do some amazing colors, sizes, and molded brick, thin brick as well. Arriscraft, if you don't know, we make a very unique material called a calcium silicate masonry unit. It's a all-natural manufactured stone. Not concrete, it's not cement, it doesn't look like stone, it's a real deal. We also employ a very unique turtleneck limestone called air. So when we look at our entire family of companies, they are continuing to grow and we're getting bigger and bigger. But one thing we do is we still make those great quality products that everybody knows us for. And so we will get into this AIA presentation today, and you'll see from all the projects that we do, excellence recognized worldwide. It's not just a local product. We can be there for you locally, which we do, but we're on a large scale trying to change the world. How great brick is, what you can do with clay products, and so forth. So, when we look at what we're going to look at today, we're going to understand the different ways in which thin brick can be manufactured, benefits of each, and then what type of installation methods we have for thin brick. So whether we want to use it in a precast panel, yes, we can do that. We can use it as an adherent veneer. We can use it in a metal panel system for the install method. We will understand why super flexible polymer 45 mortars and cement boards are far superior to the old method of metal lap, high vest, scratch down, systems, they don't understand why, the mechanisms that cause failures in that old system. Again, a lot of people are afraid of thin products, masons and needles. Here's the way we've done it in the past. It wasn't the right way of doing it. The systems we have now, they are absolutely better. And we'll talk about that. We'll talk about a system that can meet these code requirements, looking for continuous installation. And then lastly, we'll recognize that the overall design versatility of thin brick is a masonry material. So before we get into the manufacturing of brick, we're going to look at why thin brick. Well, it solves challenges, right? There's a lot of different parts of the country that just build differently. When you see it in the northern climates, you still see that full bed capital wall construction. When you get into the southwest and the south, everything's thin. And so you want the same look and benefits of a material, but you just want it as a thin product. Well, we cut thin brick or we manufacture thin brick for that reason. Maybe we have unique detailing. It's going to be easier to do, more cost effective to do with a thin product. So whether you're wanting cantilevers, slope walls, batter walls, soffits, barrel walls, getting into river windows, if you want an area with a tall wall over a lower roof, right lot lines. You want to design with a dry stack look. You haven't seen that look with brick. It's very unique. But you can't do that in traditional handset masonry because you need that brick tie to hold it back to your structure. And so with that, you need a mortar bed. As we go thin adhere to the wall, you can get that look of dry stack, which is very unique. Then we get the residential side. Bring it inside. So fireplaces, kitchens, flooring, ceilings, do-it-yourselfers. There are just so many reasons why you're seeing thin brick coming into the marketplace, and you'll see a lot of great examples with that. So when we look at manufacturing of brick, if you've never seen this process, it hasn't changed all that much in the thousands and thousands of years. You're taking a rock. In molded brick. That's definitely an option if you're going to look at that. So here's a quick video that walks you through that actual production process. These cars could be brick on one kiln car, and you've got a kiln that's about 300-400 yards long. One thing we do is we recycle a lot of that heat through the firing process, and we get it into the drying phase of this brick. One thing with brick we know is that you have to dry these brick before they are fired. If you don't dry them out, you could have an explosion in the kiln. We don't want that. And so we make sure they're 100% bone dry before they get into that firing phase of the brick. So and you can see here's the brick getting ready to get shipped out. So sorry if the sound was not coming through for anybody. But in looking at this, this is the extrusion process right here. So when we look at this die cast in the plate and we look at the core hole patterns that we have here. So these are things that change as we go to thin brick manufacturing. So yes, we can still manufacture a full bed brick. We can manufacture a thin brick specifically. So you're going to have the core holes set up specifically to be like pencil size, so we can break it and get multiple thin brick out of that fired unit. Or we can get face cuts of brick, which are a full brick cut in the fronts and backs, and we'll get there. But it's still the same process of extrusion that we're creating there. And so, again, I like to talk about the tunnel kiln because, like I said, you get about 9,000 brick on a kiln car. It spends about 34 hours in the kiln. You get about 27 cars in the kiln at a time. And a car goes in, car goes out about every 74 minutes. That's 1.2 million brick per week that you're making on one tunnel kiln. There are multiple manufacturing facilities across North America. There are multiple kilns at each one. So you can imagine just how many brick we can actually make because of the different fuels that we're now using, because of using that heat in the drying phase. We have drastically reduced the amount of energy that goes into making every single one of these brick. Again, a lot of times we have numbers being pulled for the manufacturing process of brick that are old, like 60s, 70s, when they were making brick. What we make today is much different. That process has gotten greener and greener and greener. And so a lot of people don't think of brick being that green. Well, they absolutely are. They are one of the most sustainable products we've ever had. And so when we look at this manufacturing process, again, it's much different. Even the standards from 100 years ago, they do not compare with how we make brick today. I mean, we used to have brick fired in a beehive kiln. With that, you can see in the middle photo, they're throwing some wood in there. It's heating up around that point. It's not consistent throughout the entire kiln. You know, it's going to go up to the center. It's going to fire some of those brick, but definitely not a harder fired brick. Those are basically salmon brick. They were used as the mass of the wall because that's how we used to build, right? We built mass walls. So multiple widths of brick to create the mass of the structure. And so those salmon brick fit in there, but they weren't really hard, dense enough to be used on the outside of the building. So when we look at that, the quality control was kind of all over the place. But yet, when we look at projects, we're still standing over 400 years from a method of manufacturing that was nowhere near as good. I mean, look at thousands of years when they used to bake the clay out in the sun. Projects still standing today. I mean, quite amazing when we look at today's brick. We use natural gas, the hotter, cleaner, easier fuel to use, greater testing methods, state-of-the-art drying and firing monitored by computers. I mean, how long is today's brick going to last? If we have had brick standing for thousands of years from a process nowhere near as good as this, I mean, wow. This is what sustainable building and materials are. Something that's going to last a long time. And so when we look at brick, one thing that's also very unique about it is the way it can be recycled at the end of its first life cycle. So it has multiple life cycles. You can't just base it on one because you can do so much with it. So you can use it as brick nuggets for landscaping. You can use the brick dust for, you know, MLB, the French Open. I mean, the French Open, you go to that, they'll sell you clay powder for 25 bucks, a little tiny vial. I mean, I guess I'm on the wrong side of the business trying to sell you a full brick. I should just get into that. I mean, that's expensive for a little piece of clay powder. So there's so many ways that we can recycle and use brick. One important one is using those brick chips, putting them back into a raw material supply. It's called frog. We use this a lot because it actually helps lower the firing temperature of even new brick because they've already been fired. It also helps keep colors more consistent. It's a way for us to recycle and reuse that product. So very unique in that way that brick can find multiple avenues for being recycled and reused. Again, we talk about sustainability because marketing is so good. There's so many times that we get fed a diet of this is good for you, this is right. And then you actually look a little bit deeper and it's not. So it's the same that goes with building materials. We have a lot of products that are being promoted in the marketplace that are supposed to be green, they're supposed to be good, they're supposed to be sustainable, but they really aren't. There's a lot of maintenance. There's a lot to them. They aren't going to last. They aren't going to perform. They don't have the history of performance like you do with brick and stone. I mean, we always put this little slide in there as so much for a wood henge. You never hear about that, do you? No. You hear about Stonehenge because it's lasted, it's performed. There's more to value than just a price point. And so when we look at brick, it has been the superb, sustainable material for thousands of years. It was sustainable before we even had a word called sustainability. This was the product that everything is based on. If you are designing for sustainability, this is the top. This is what you use. You use clay brick. And so when you start looking at the amount of energy that goes into manufacturing these materials, it's actually very low, especially when you start comparing it to other materials. So 900 BTUs per pound of brick produced, that's less than concrete, glass, steel, aluminum, and even some wood. I mean, that's quite amazing to think about how little the amount of energy goes into that. And so when we look at what sustainability is and trying to meet the needs of the present without compromising future generations to meet their own needs, these are the products we should be using. We need products that are resilient. They can stand up to nature with minimal damage. We need products that can go into the sustainable overall building. They're energy efficient, water efficient, resource efficient. Something that provides great thermal and acoustic comfort, indoor air quality, appealing aesthetics. So we need to look at all of this, and not just in the initial phase, but throughout the entire building's life cycle, including operation and maintenance. And so that's why I always try and promote and talk to people about the E4 principles, because there's a lot of things out in the marketplace, 4Rs and so forth, of what goes into sustainable building. Yes, there is cost, the economy. Well, guess what? Brick, economical. The actual material itself is amazingly affordable. Labor costs have gone up, but that can be said with any part of the building industry. But the actual material itself is very economical. When you look at the ecology, we're always trying to do the best for the environment. What we're taking from it, we want to give back even more so. And that's one thing that with clay, if we take a cubic yard of clay, we get as much of it than a cubic yard or more out of it, what we're actually producing. Energy performance. No other materials can compete on the energy side when we build our walls properly with clay materials, especially if we're designing for passive house standards and so forth. Technically, a perfect wall is, cavity wall, continuous insulation, outboard, 4-inch thick veneer, have your true rain screen. That technically is a perfect wall, and brick fits into that, absolutely. But then it's also emotion and health. When you see a brick building, it's healthy, it's comfortable, it's safe, and it's beautiful. I mean, that's one part of my job that I absolutely love doing. It's beautiful. Brick, stone, these products, I don't have a hard time selling people on using them on that because they sell themselves. They're beautiful. You want these materials, It's not like stucco where, hey, I get to meet a designer that says this just accentuates my building. It's so nice. I love using that stuff. No, that never happens. Usually I wish I had the budget to build with, more stone and brick and do some cool, unique things. Well, let's talk about that because, again, it is economical. So let's have more of a conversation. Sometimes thin products allow us to realize some of those cost savings. And so depends on the market, labor, wall system, and we'll get into some of that. So when we look at thin brick, this isn't a brand new product. We've been doing are making thin brick for quite a long time. I mean, here in the US, back in the 50s, when it was really kind of started really making it and pushing it. And there's a way to reface existing structures, different applications, new, old, residential, commercial. I mean, it gives you the aesthetics of traditional brick, but maybe some economic benefits for having a thinner wall assembly. So when we get into producing a thin brick, you have two options. You can take a full brick and then get the face cuts of it, or you can actually extrude a thin brick. So this is the first process. Taking a traditional full bed thick brick and cutting the face off of it. Now, we can change those core hole patterns, as you saw earlier. We can play with those. We can squeeze them down, open them up, and you'll see when we extrude it, how that definitely changes. Just like with this, if we want a flat back or a dovetail back, we can provide both of those. And so we can give you that full L-shaped corner because it's coming from a full bed brick. And so combining the two is very easy to do. You'll see we can do scratch backs if needed. Quite honestly, when you start looking at PCI requirements and pull out strengths and so forth, that scratch back doesn't really offer anything, but some people want to see that. So we can scratch the backs and do that in both a smooth type of face or even that old tumbled type of look. We can do it both ways. So there's a lot that we can do with thin products in that way. So now that's cutting faces off the front or off the back. I mean, we can use both sides of that brick that we've been using. You'll see a couple slides we do that old beat up tumbled. We typically use fronts and backs there. As we get to extruding an actual thin brick, you can see we're just changing that cast plate that we're going to extrude through. You'll see those core holes are slightly different. So the only thing holding the faces together is a smaller tensile strip of brick. And so you take that, you snap them, and there are your two products. Some plants can make two, some make four off of that, but it's the same thing. You're going to extrude, you're going to fire, you're using the same materials, you're getting the same brick, just thinner. So multiple methods of how we can make thin brick materials, extruded or face cutting. So when we look at thin adhered, there have been many advances in thin brick methods. So how we install adhered veneers has absolutely changed. We are not, we'll talk about it, but we are not promoting or doing the system of the past. We have better systems that are turnkey, complete assemblies. They include warranties. We can provide face sealed assemblies, drainage plan assemblies, insulated drainage plan assemblies. I mean, you name it. We can meet a lot of different types of wall assemblies using thin materials. Some of these products have been tested for Dade County, so hurricane and wind loads, NFPA 285, fire ratings. There's a lot that we can do with thin. So when we look at thin, though, the people that are afraid of using thin products in freeze-thaw climates, higher than a couple stories and so forth, it's because this old method. This is how we used to install thin adhered products. We know this from the cement, the cultured, cementitious stone industry. This is the method. We do this with quarried stone. Same thing with thin clay brick. But when we actually dive into the system, the actual assembly, we see a lot of issues with this. So you have your belt, your tie bar, that material, the way you put it on your wall, you have to put a bunch of holes through it. So you have to nail it, you have to fasten it somehow through that wall. And what we do is we puncture millions of holes through it. Well, when you do that, you can't really have a good waterproofing assembly. You're creating a sieve, right? Water can go right through that. When you look at air pressure in your wall that you can pull moisture through, right? Well, if you don't use the proper materials here, that can happen. And so it's tough to actually seal up all those penetrations. I mean, you've never been to a job site and seen a guy with a huge thing of tape around his arm. All right, let's see, you got 2 million holes to do today. No, you're never seeing that. So Are we truly getting air barrier status? No. As we get to building science, we're looking more into air barrier, vapor barriers, and so forth. We need to make changes and get away from those types of products. Now we get to metal lap. Let's say you button it all up. Well, now you have to apply that to your structure. How do you do that? Well, now we go staples sometimes, nails most likely, and you're penetrating it through that waterproof material that won't seal around it. That's not ideal. Are you hitting studs? What's a pull-out strength? What are the wind loads for metal lap and that type of substrate? You don't have answers to that because nobody wants to talk about it. This is just a cheap way of doing it. So metal lap is going to likely rust because it's not fully encapsulated in mortar. It's pinched against the wall, we smear mortar over the top of it, and we call it good, right? Well, that's not encapsulating the metal in that cement. So it's always a point that it can pull apart because it doesn't actually bond together. It can encapsulate, but that's the failure point typically. When we look at that metal lap and the scratch and brown coat over the top of it, code requires you to let that wall cure before you bond something to it. It's 7-day minimum, recommended 28 days. Have you ever seen a job site stop for 28 days to let that cure before you bond something to it? Never. You're lucky to get a lunch break before we go over the top of it. So it's not dimensionally stable. It's not what we should be doing. There's no warranties for metal lap and mortar beds. There's no system or assembly warranties. There's multiple steps, and guess what? We can't really put insulation in that wall. So we look at the failures of curve. It happens. We've all seen it. Well, we look at the reasons why. Well, we talked about the systems and the materials, but when you look at cement dry set, type N, type S mortars, which is what we typically always use, well, they barely meet code requirements of 15 PSI per pull strength. It's the most ideal material to use in a state of compression, right? So you got brick and brick stacked on top of each other in a compressed state. Ideal material to use. Holding a unit on the wall, it's not the right product. But if we start adding polymers to the mix, well, all of a sudden that changes things. Now it's becoming more flexible and has more movement in its hardened states, deformation capacity. But what we have to do is we can't just add some polymers. We need to be using these super flexible polymer mortars because that gives us the belt and suspenders, right? The things engineers love, a little bit of a safety factor, because when we look at how materials move, the larger the units, the more they're going to grow and shrink. And just on temperature, that unit can shrink down on a hot day, south wall, rain hits it, it shrinks. The mortars need to have enough polymers in it to actually move and adapt with it. Here's an example of a job that uses a thin clay tile unit, and they adhered it with these super flexible polymer fortified mortars. This is a Bullock store, the Northridge earthquake. This is about the most extreme example that you can get of building destruction, right? Went through an earthquake. Yes, we can talk about the destruction of the building. The one thing that we want to look at here is how the mortar performed. Not a single piece of clay tile came off of what it was bonded to. Not a single piece. The entire building came down, but not a piece of clay tile came off of what it was bonded to. It sheared completely through and it went into rounding. These mortars are insanely strong and insanely flexible. They're the products that we should be using. So when we look at the improved system that we've been promoting and using for the past 10 years, 20 years in some parts of the country, this is a better system. We need to get more people up to date on what this is. And so we're looking at a steel center wood stud, your exterior grade sheathing, and then a cementitious board. These cement boards are cured before they come out to a job site. They're dimensionally stable. They're typically 3 foot by 8 foot or 4 foot by 8 foot. So you're putting up 24 or 32 square feet at a time. Less steps comparatively, so you can reduce your wall costs almost 30% from some studies by using a cementitious board. And guess what? That board will give you a warranty. I mean, that's almost a no-brainer. On top of that, because it's a flat surface, it takes up some of the issues in the wall, the studs not being even and right. So when you're laying a bunch of little brick, you get less lippage in the wall. It makes so much sense going to cementitious boards. They're just better products in that way. Now for a face sealed assembly, we're going to take that cement board and then we're going to put the air and water barrier over the top of it. This is unique in this example because this air and water barrier also has the same polymer fortified mortars as the polymers as the mortar. So you can bond to a cement board, mortar can bond to it, and it will not delaminate. And so it's very unique having its placement right there, and it makes a lot of sense for a face sealed assembly. Over the top of that air and water barrier, you have your polymer fortified mortar, and then your thin brick, and then your point in your joints. That is the system we need to be using. And the benefit is chemistry. We look at these polymer modified adhesive mortars, they solve problems. They are much, much stronger. I mean, we've seen jobs where it shuts down a hydraulic lift because it gets stuck on the face of a brick or stone. The old systems, you have a kid at Chuck E. Cheese pulling product off the wall. Those aren't the right products to use. These are. Increased deformation. We need materials that can expand and contract, that can move with the materials in the wall. Air barrier answers code design challenges. We're about to talk about an insulated cement board panel that solves that continuous insulation challenge. How do we meet these new code requirements? Well, we're going to talk about that here in 1 second. So on top of that, you can get a complete system warranty. 15 or 25 years, covers material and labor. That's amazing, especially as we go to thin products. So that's what we're looking at. That's what we're trying to promote and use. And lastly, those mortars are resistant to the effects of freeze thaw. They're chemically bonded, not mechanical bonds that can be pulled apart. And so when we switch away from the older materials, we go to new materials. Again, we've gone to self-healing liquid applied air water barriers. We have products that are vapor permeable or vapor impermeable, like a vapor retarder. We've added a cement board, so we eliminate the metal lac, the thing that can rust and deteriorate in the mortar bed. We have products that are showing up that can be installed that day. They're dimensionally stable. Greater bond strength. These mortars are made to hold masonry products on a wall. So again, this is the right system to be using. Now, with that, a face sealed assembly doesn't have drainage, doesn't have continuous insulation, but we can add that to it. So when we look at how we currently build, we're seeing a lot of things change across the country. Obviously, the northern climates, we've been doing more and more of this over the past few years. The southern climates, we're just now kind of getting into it. But when we look at how we currently build, we can see all the energy that we put in these buildings are escaping out. So everywhere you see red is heat flowing through the wall. So that's your thermal bridging occurring in your wall. And you can see all the different areas. Well, we need to clean this up a little bit, and we can't. When we look at the amount of energy that goes into the built environment, it's significant. It's almost 40% of all the energy consumed. It's a lot to heat and cool and light our buildings. Heating and cooling broken down into that built environment is almost over 20%. Just to heat and cool our structures. Don't you think we should change the way we build those to be better for passive designs so we aren't heating and cooling as much? Well, that's kind of what we're getting to. So when you look at the energy codes, you can talk about ASHRAE 9.1, IECC, SB10, NECB. We're all trying to get to the same point. We're going to talk about ASHRAE 90.1 and the prescriptive path coming through. For an example, instead of going through every single one across North America, we're going to pick the one that has the most paint on the board, and that's where I live here in Denver. It's 70 degrees one day, and then it snows 2 feet, and then it's gone back to 70. You gotta love it. So 4, 5, 6, and 7, we'll pick climate zone 5 just out of all of them. So we look at code requirements. How can we meet these new energy codes? We can have an assembly maximum, and it requires a U value, basically thermal modeling to show how it performs as a wall assembly. Or the prescriptive path allows us to just hit an insulation minimum R value. So R13, which would be inboard, plus 10 continuous outboard. If you do that, you just met code requirement, move on. So we have a system that we can meet continuous insulation. So what is that entry code solution? So this is a insulated cement board with drainage. So as your wall is designed, we move that air and water barrier over the sheeting, because we're going to treat this as a rain screen, almost like a cavity wall construction, right? You have your continuous insulation, your drainage, you're going to flash this out. This is the same detailing. So that perfect wall from a building science standpoint, that's what we're trying to replicate here. So you have your air and water barrier over your sheeting, and then you have this insulated cement board panel that can be done with EPS, XPS, or mineral wool. It's laminated to the cement board, and the drainage grooves are cut out on the front side and the back side. So you get 2 layers of drainage laminated to a cement board. You're going to tape and mud your joints, and these are getting fastened into your stud. So you aren't relying on adhesives for the whole assembly. You're actually mechanically fastening this insulated cement board panel into a stud. And so that's part of the beauty and engineering of the system. So alkali resistant mesh tape, tape and mud your joints, have your polymer fortified mortar, and then your thin brick, and then you're pointing your joints. That system right there meets today's energy code challenges by getting thin brick. And guess what? It's NFPA 285 compliant. So we've actually gone through the burn testing, and we have the engineering judgments for various types of masonry materials that'd be going over the top of it. So we know thin brick, they aren't going to burn. We know that natural stone, calcium silicate stone, same thing. So we have the engineering judgments to make it easy for you in your design and the materials that you can select. Now, when you look at putting materials over the top of this insulated cement board panel, you'll see in these examples, nothing changes other than the veneer applied to the board. And so we can apply thin clay brick, thin calcium silicate masonries, thin quarried stone, thin porcelain tile, thin cementitious stone, and then acrylic stucco over the top. Nothing changed in those examples. There are a lot of great stucco systems that are out there for stucco. There's only one system out there that's great for all masonry products and stucco, and that's what this one is. Designed for thin masonry veneers. It's the right product to be using there. So we can help with details, design. We have all them laid up in our CAD library. Show a nice flashing detail here. Using a base suite panel. This just makes it easier for the installers. A couple things that also make it easier on them is chamfering the edges of the insulation. So as you put the boards together, you don't have to worry about blocking drainage grooves. You can just put them together. Moisture will pick its own path as it hits that chamfered unit and go where it wants to go. So as we get into some projects and looking at thin interior veneers, I mean, you look at this building, it almost looks like an old warehouse. This is a brand new job, all thin brick. I love the use of the different borders. So the main entrance area right here, you'll see is a one color with a white border. You see the building to the left, and then kind of in the back to the right, that's the same exact brick color. The only difference is that's more of a black border, not a white border. What a contrast, right? Same exact brick color. It's amazing how much mortar can impact the overall look of the wall and the materials. You go inside the structure, they wanted to carry brick throughout. They wanted that old warehousey look. So they got this beat up, tumbled brick. They painted it. That's an option these days, absolutely. But when we look at the mortar, so you can play with the colors of mortar to create contrast. You can play with depths of mortar, so rake joints and flush joints. You know, Frank Lloyd Wright, famous for that, all horizontal rake, all flush heads. So as we go thin, though, can we just remove the mortar joint? Yeah, and get a dry stack look. You can absolutely get that. And you can take a brick that can be old, beat up, tumbled, and make it look just modern. I mean, this is a whole new take on brick, right? You don't see this very often. Well, because you can't do that with full bed, you can achieve that with thin products. So dry stack look is absolutely achievable. Some other great examples. I mean, look at these Gothic arches, thin brick around this entire building. Love these skinny columns running up and then seeing the brick, and then love the lighting that they added to this as well. You know, great national brand chain. Hotels, same thing. You see a lot more materials being brought to the inside of the building. You can keep full bed masonry on the outside and then bring thin brick to the inside and tie the same exact product between both. You can use thin brick outside and thin brick inside. The combinations are endless of what you can do. Again, here's another great example, a nice soldered unit as a band or a course, but I love this project. I love those bay windows. You know, a nice brewery. I can't wait to go out and start drinking in the summertime, sitting in one of those bay windows. I'm sure all of us have that same exact feeling. We want this to be over. We want to get back out and enjoy ourselves and socialize and, you know, sit in that nice bay window. But the arch above, I mean, I just love this project. Details. So yes, we can do a lot full brick. We can do a lot with thin brick. Actually, quite honestly, some of the detailing that you can add with thin brick is much easier because you're just taking the space cut, you're putting your mortar on the back, 100% coverage, and then you're just sticking it to the wall. So if you want to do your standard half bond pattern, that's upper left, you can go down to the bottom left, the basket weave pattern. So some shouldered, some not. Well, then you go over to herringbone pattern. So now they're stacked this way, a stacked bond. These are easy to do with thin products because you're just walking up through your wall and you're setting it however you want. It's pretty easy to do. So here's a great example of a job in Denver. It's an affordable housing project. I want to tie in this, you know, downtown area using a red brick, make it fit in. But they used some nice detailing with this darker colored brick. They soldered it, used it as a band. They did a herringbone pattern up here below some of the windows. They used some thicker units, right? Create a projection on the wall. It's all thin. You get up to this horrible detail up here towards the top. This is all thin brick. Now, one thing to note, you don't see corners at these windows, right? Well, when we look at a lot of these types of jobs, you'll see this a lot on certain types of multifamily retail, hotels. It's a cost savings by not including all the costs of the corners because they do cost more than flats. You know, traditional masonry, the thickness is your corner. Well, now we're cutting that out into an L shape. They do cost a little bit more money. So bringing your windows flush, well, that can save you a little bit of money overall. So that's all thin adhered masonry. Now we go to metal panel systems for thin brick. And there are a lot of them out in the marketplace. They all have their warranty, their systems, their engineering that they can provide for it. Some have some great benefits. One beauty is they make the install a little bit easier just because you aren't having to plumb and level every product. It kind of takes care of that for you. So that's kind of the beauty of it. And so when we look at metal panel thin brick assembly that can meet code requirements, so we're going to put insulation in the wall, it's still basic, same premise, right? You have your sheathing, your air and water barrier. They have a foam insulation adhesive. This is going to hold the insulation in place as we're building the other layers over the top of it. So don't forget, you put insulation outboard, you have to have a drainage plane somewhere in that design. And so in this example, it's going to go over the top of the insulation and behind the metal panel here. So insulation, drainage, metal panel system. These metal panel systems will be fastened back into your studs, into your structure. You take this adhesive on the back of the thin brick, dab, swivel, depends on which one you're using, and this is going to adhere this onto the metal panel. Now, what creates the mechanic are these half shapes that you pull down that the brick rests on, and then when you add your pointing mortar, that locks the whole system in place. And I mean, this is an engineered system, so you can see it going up here. Here they have their sheathing, their waterproofing, their metal panel going up. They're putting the thin brick in place. See how it's resting on those little half moon tabs that they're sitting on right there. So you come back, you can see them pointing the joint and then tooling the joint, and it looks just like a full bed brick, and you'd never know. None the wiser. What a great system for doing it. So lots of great examples of how this system goes up. You can do different bending. You can add different materials to it. You can add some stone in there. there's a lot of things that you can do with these systems to make it not look like just a metal panel thin brick going up. We can do multi-story work with this system too. Again, that's part of the engineering, depending on the systems you're choosing. We've done some low-rise, mid-rise work with these metal panel systems in thin brick. Again, you look at an old building like this, hard to tell that this is all thin brick, all brand new. Great way to tie in the past and the present, take some efficiencies of thin. What about that hand molded look, kind of that sanded face? You can absolutely still get that with thin brick like you see here. So we have it here. We have metal panel systems for putting the brick into, and now we can get into precast. So we see a lot of precast, and we've been involved in a lot of precast jobs across the country. You can absolutely embed brick, thin brick, in the precast elements, and you can do some very outrageous, wild thinking things with brick. You can almost do a little bit more than you can with a handset masonry because it's actually embedded into the overall wall assembly, not a handset unit, different ties. You can achieve it both ways, but precast does have some benefits to that. So we look at the two types of brick that go into precast. You either have a saw cut thin brick, or as we showed, an extruded thin brick. There are some slight differences between the two. So when we see a saw cut thin brick, yes, it's manufactured as a full-size brick. Well, of course, for yields, we can get fronts and backs off of it and not have much waste when it comes to that. And then we can use it as grog and refire and so forth. So we can always find ways to recycle and reuse what that is. So don't let that push you one way or another. But when you get to a saw cut thin brick, the textures, the colors, the same, flashing, those are all available. It can't be said the other way. We can tumble it, beat it up, give you that rustic look. We can also give you the straight edge units, solid colors, more architectural type of style as well. We can give you different thicknesses because it is a full brick. We can give you different thicknesses to create some different projections and reveals on a job. If you do full brick in certain areas, it's the same exact brick. So you'll see a great project coming up. Half the job was precast, half the job was full. Most people would never know, well, which one went where. We'll see if you can tell in the pictures coming up. So again, we can cut those into flats and corners. We can wax the faces, and we can give you various shapes. So to get to an extruded thin brick, so it's cut in line from extruded logs. So 2 or 4 bricks, not a lot of waste, just that little pencil mark. You snap it, you break it, move on. So very little waste when it comes to that. Primarily straight edge, so you don't get a lot of different textures and looks to it. You don't really get full bricks to match it or correspond with it. But this is the most popular type of precast thin brick. I think that's also because not a lot of people know that you can use a saw cut thin brick. When we look at manufacturers of full brick, a lot of them don't have tight enough tolerances to even meet TBX, which is a high standard for thin brick, let alone go into PCI, which is even more extreme when it comes to dimensional tolerances. So typically you always see these extruded thin bricks because they have tighter dimensional tolerances. Well, there are some manufacturers that make thin brick that can still meet PCI requirements. And so when you look at the assembly of how we do this, you have your thin brick, it's waxed face, and it's set in the liner. So that waxing of the face is very important because as we build this wall and then we pull it out of the liner, we don't want the liner to come with it. So that waxing of the face really helps. So there's your thin brick being laid down into that liner. Then you have your face mixture that's going to be poured over the top. The face mixture is going to be your mortar joint. It's concrete. It's not mortar. It's much different material. It looks a little bit different. You can acid etch that if you want it to look like a traditional masonry mortar joint around each brick. It's going to be a different bed. There's slight nuance and differences there. You can color that to get different colors in mortar as well. So that's an option. Then you have your rebar being built over the top. And then you have your second layer of concrete. It's going to be the full width that's embeds rebar in. And then you lift it up out of that liner and there's your wall assembly. So we can also meet code compliance and add insulation continuous insulation into that wall. It's basically a sandwich panel. So we start with the same thin brick wax set and a liner. You have your face mixture, but you also have these insulation pin connectors that are going to tie through the multiple widths of concrete. So you have your pin connectors, you sandwich your insulation in there, do your rebar, and then pour your concrete over the top. And now you have a sandwich wall panel with continuous insulation and thin brick embedded into that. So again, as we're seeing more and more designs meeting these code requirements, we can absolutely do that. Thin adhered metal panel or precast. So here's a great example of brick getting set into the liner. You can see these liners right here. You can see how quick this goes up. It's done in a manufacturing facility, not on a job site. Here you can see the corners getting installed. I mean, this is pretty fast for installing this much brick, right? So you can see the lifting arms that they're putting in. Here comes your first face mixture of concrete being applied to it. You'll see there, that metal section right there, they're going to use a different color in that area. So they're aerating this so they get all the bubbles and everything out of the mixture there. Then they're going to put their rebar down. Then they're going to come over the top with their second. You see this color is white. So this one's going to actually be exposed to some banding running through the material. You see it getting lifted out of the liner, shows up to a job site. They're going to lift it, crane it into place. Here it is getting brought in, set down, and then it's going to get tied back, welded into the actual structure. That's it. That's how we do precast. So with that, some of the benefits of going to a socket thin brick, yeah, you can get the straight edge, but we can also give you a textured distressed look, or we can give you a tumbled look as well. That's the part that's so unique. A lot of people don't think you can get a tumbled, beat up thin brick put into a precast panel because of PCI requirements. We absolutely can do that. And you'll see a couple of these examples. I mean, this is a cool look that you can do. Here's an example of McKinney Stadium Enterprise Precast. Again, this job had both full brick and precast on it. Most people walking around would not be able to tell what's what. That's the benefit of using a full brick that's saw cut. Love this detail as you get the inside corner condition, pulling it in a little bit and creating that zipper effect. So that down light or the up light, it's such a nice look. Tile build, I mean, a lot of the stadiums that are built are done with thin brick because there are benefits to it. Again, detailing. What can we do that's different? Well, here's one that's embedded. So you can embed thin or brick into precast and create this look. So many things that can be done. Again, we get the PCI thin brick specifications. There are a lot of them, but thin brick can absolutely meet PCI requirements, even for dimensional tolerances. As you go to obviously a beat up tumbled unit, well, the corners, the edges, you know, they're a little bit more beat up. And so, yeah, they're slight voids. Well, we can get past that with these form liners and not have to worry. So we can definitely meet PCI with thin brick with all different looks of thin brick. When we go to benefits of precast, well, certain jobs, there's definitely overall efficiencies that can be had with it, whether it's labor, can be cost effective, it can be done faster. Some of these jobs can be done about 60% faster by going to precast. Again, we can add continuous insulation in there. We can have strong walls that are fire, seismic, tornado, blast resistant, and we can do almost any pattern with it. So yeah, you can do precast and you don't have to be relegated to what they tell you on the pigment color of the concrete would be. And, you know, hey, we can add this little detail that kind of looks like brick. It's not the same thing. Many people have tried to copy the look of brick, but nobody can actually give you the same thing. There's a warmth, there's a texture. It's from the earth. There's something different about it that nobody else making other products to make it look like it. They just aren't the same. And people realize that. So instead, your overall wall cost for doing this type of assembly and adding thin brick to it It's not a huge difference. And so why not start adding more of these precast thin brick to your jobs? You don't have to just accept what they're telling you. You can absolutely get thin brick added into those precast assemblies. I mean, here's a good look at that beat up tumbled brick. Cool details. Again, there are a lot of questions about how to create that, those sharp irises, right? So the edge of the brick, that tight iris. Well, they actually installed it a little bit different. So you can see the form liner that they used here, how they made this very unique type of look here. Easy to do in precast applications. Ball Corps headquarters in Broomfield, love this job. You can see that nice banding running through where some of the panels were coming together. You can see these kind of the passive sunscreens over the windows as well, but kind of floating corners that you can see with the brick up above and below. Great detailing on that. I mean, here's a University of Alabama parking garage. I mean, I guess UNMA national championships, your parking garages look this nice, right? You know, I'd say roll tide, but there's people all over the country here. I don't know if I should say that or not, but quite amazing. What a beautiful project. Ties in something, you know, historic, but it's new. Take the efficiencies. LPL Financial, North Carolina, same thing. Using a lot of glass and tying it in with brick and masonry. There's something about brick and stone and glass. They're just so perfect together because one is so sleek and the other one adds that texture, that warmth, that feel. Combine those two materials. It's easy to do here. And I love that condition with the window. City Field. Look at all these arches. Again, there's reasons why precast can offer savings. It's certain design elements, like all these arches. To do that as hand set masonry, I mean, we aren't the Romans. You know, we don't build everything with it the old way of doing it. Take the efficiencies of design and construction methods by going to precast elements and doing it that way. You still get the beauty of that brick. Again, another great example. You see that nice step back in that breezeway going through. Museum of the American Revolution. I mean, this is a brand new building, but they wanted it to look old, like it's been there for hundreds of years. Well, they definitely accomplished it because of the type of brick they used. They wanted that kind of hand molded, sanded facing brick. They put in a Flemish bond pattern to tie into the era, the time of way. Beautiful, great way of old and new. And then here you have Sealy's headquarters. This is timeless. I mean, that is a beautiful, stunning building and will forever be. It's never going to go in and out. It's always going to be just a beautiful looking job. And you can see that beat up tumbled brick in that precast element. So lastly, just to touch on as we get to interiors, flooring, ceilings, there's a lot that we can do with brick. I mean, having a brick flooring, I know a lot of people haven't done it, but why not? I mean, we use brick pavers outside and they're amazing. They're stunning. They last, they perform. They're so great. You can bring that to the inside as well at all your entrances like this. You know, you can see this nice office right here, the brick on the wall, the brick on the floor. Great use there. Well, brick on the wall, brick on the floor. What about brick on the ceiling? Absolutely. I mean, I love this job. They had a unique core hole pattern for this brick. They used it then and they put it in the ceiling elements. You have it as a paver, you have it as your wall, you have your interior flooring. I mean, use brick everywhere. This is what I'm talking about. This is the stuff I like, right? Again, with those bay windows there, interiors, downtown, new hotel project. How to make you feel like you're in that old warehousey type of building that's been renovated, brand new job. I love this. I mean, the barrel vaults. It's a Catalan vault, different ways of doing it than brick. But I love looking from the outside of this building to the inside, seeing the brick on the wall, and then seeing the brick in those vaults. I mean, it's just, I want to work out of there. That should be my office. I don't think this one's quite doing it for it. But lastly, outside the box. I mean, as I said, that Catalan vault, this is all thin brick. The way it's designed to overlap 3 different layers actually allows it to have a structural element that you can actually walk on. And they used to do this because they'd store stuff. It's great, disperse in that way. So what you're doing outside, do inside. Use brick everywhere, floor, wall, ceiling. Where can't you use thin brick? And so just to wrap this up a little bit, we do have another new presentation, which this one was as well, that is look to the interiors. So thin masonry for internal beauty and design. That's coming up here June. Make sure you sign up for that one. It's going to be a great presentation that focuses purely on the interior side for interior designers of what you can do with masonry products, whether it's thin brick, natural stone, thin calcium silicate, you name it. We're going to show it all off on that. And definitely continue to follow us with these webinar Wednesdays. We've got a lot of great feedback with it. Continue to show up week to week. I hope you've enjoyed all of this presentation. Hope it enlightened you to some new possibilities of using thin brick. And as I continue to say, let us get involved and help you with your projects. Yes, we have all different types of masonry materials, but the quality of our service, the quality of our materials, the quality of our salespeople, it's different. We add value to your project. So let us get involved and be on this journey with you of design. So if you have any questions, we will start taking those now.
All right, thank you, everyone. If you guys do have any questions, just post them in the Q&A, and we'll see if we can answer them. Steve's here to answer them for us. Okay. Well, no questions have come in. So thank you very much, Steve and Arriscraft, for this presentation.
Thank you, Brent. Beautiful presentation.
All right, guys. Have a good day, everyone.
Thank you.